Looking good. There we go. Getting more answers up there. Thank you. Thank you. Awesome. All right. So let's go ahead and go over these questions here. So we have a compound, phosphoric acid H3PO4. So we want to identify the names and the number of each of the atoms in this compound. Taking a look here, we have H, and H is definitely the abbreviation for hydrogen. Remember, this is an example of a single letter abbreviation, right? You can have double letter abbreviations like HE, which is a capital letter with a little letter, a lowercase letter. And in that case, the number would have to come after the double letters, all right? And this would not be hydrogen, this would actually be helium. Smiley faces emojis in the chat if that makes sense. You can have single letter or double letter. Single letter or double letter. Again, the number only comes after the double letter if you have a double letter. Cool. P is for phosphorus. That is definitely true. Absolutely. And O is for oxygen. Yes. So we know what the atoms are. Now we just need to figure out how many of each there are. So taking a look here, the number after H is a 3. So definitely we have 3 hydrogens. Perfect. The number after P, all right, which is a single letter abbreviation, right? So we don't have to worry about a second letter there. But after P, there is no number. So blanks mean what? Tell me in the chat. Blanks mean what in the chat? Thank you, Monse. Let's get some more answers. Thank you, Marina. Blanks mean how many? Thank you, Julie H. Excellent, Ronnie. Yes, blanks mean 1. Again, it doesn't mean 0. If it meant 0, we wouldn't put the P in at all. So in this case, phosphorus, there is 1 phosphorus and phosphoric acid. And last but not least, there's a 4 after the O, and so definitely there are 4 oxygens. Go ahead, give me a green check, orange X if that review makes sense. We started off a little bit slow with that, so I want to make sure we're all comfortable with that. Thank you, thank you. Green checks, orange X's. I'm going to send out the links to the notes as well in the chat. Feel free to start raising your hands once you have those open and ready to go. This is a reminder that you can get notes credit at any time of the trimester. Even if you turn it in after it's due, you'll still get however much you earn on your notes normally. However, if you also want attendance, you do need to be doing them during class. So make sure that you are doing your notes during class. Excellent. All right, looks like we're feeling more confident about that. That's what I love to see. Let's go over some announcements.
All right, guys, good morning and welcome. As always, please do not share any personal information during class. Your participation is required, and these Connect sessions are always recorded for learning purposes. All right, looks like we're on Tuesday this week, and we're starting our second lesson of this unit for ionic bonds. All right. As you can see, going forward, we're going to be learning all about all different sorts of bonds, but we're starting out with a simple one. All right. This will entail calculating the overall charge of an atom, being cations and anions. We'll explain how ionic bonds are formed. So just based off of how the names look, using the same common name of ion, it probably has to do something with that. And then finally ending with explaining how metals and nonmetals lose or gain valence electrons during that bonding. All right, and hopefully by the end we should all be proficient at what we are learning about in this lesson. Please raise your hands for your notes so we can have confirmation that we are all ready to participate before we start the lesson. It will give us about 30 more seconds, and then I'll start calling on people. So please do not hesitate to raise your hand when your notes are open. Also, yeah, if none of the links work, neither my link or the Larkin link, you can always go to your grades tab if all fails. Start talking about how electrons are what? What's the charge of an electron? Based off of this picture, let's start off easy. What's the charge of an electron? Yes, it is negative. So electrons are negatively, I think I spelled that right, not quite. Negatively charged. So moving forward from that, let's work on these two questions by just answering in the chat. The first one specifically. So if a neutral atom gains electrons, knowing that now that they are negatively charged, then they should be what as an overall charge if we're gaining electrons? Neuro is kind of finicky. So think about if you are gaining more negative friends, do you become more of a positive person or a negative person? And Ronnie, thank you for that. Julia, Marina. Right, exactly. You're going to be more negatively charged. Good job with that one. Now, if a neutral atom loses electrons, right, you're eliminating the negative people out of your life. Do you become more positive or negative? Exactly. You're going to become more positive, so more positively charged. All right. So this is the main concept that we are going to be working with this entire lesson. If you understand this completely, then you should be fine mostly for rest of the lesson. There's going to be a little more vocab, but this is the main concept behind everything. All right. So just confirming that we got the correct answers there. So just reviewing what electrons do in terms of ions. Atoms that are neutrally charged have equal amounts of protons and electrons. So if I have the same positive charge as I do a negative charge, then it doesn't matter how much I have of each. As long as they're equal, they're going to cancel out. We can calculate this using our simple equation up top. Remember from last unit where we take the positive charge of the protons, add that to the negative charge of the electrons, and the sum will give us the overall charge. All right. And just a small review down here that any atom with an overall charge that is either positive or negative, it will be called an ion.
All right, so let's go ahead and talk a little bit about calculating charge. This is something that we've actually already reviewed, right? But this is something that we're going to go ahead and go over again just because it's related to talking today about ionic bonds. So remember, ions are an atom with an overall charge. If something's neutral, it's just called an atom. Once it gets a charge, then it's called an ion. Just so you know, if you mix them up, it's not a big deal. Most people will understand what you're saying, but technically an ion is an atom with a charge. So let's go ahead and imagine we have our neutral atom that has 8 protons, 8 electrons, right? Equal amounts so that it's neutral. But then we actually gain an electron. So now we have 8 protons, 9 electrons. Go ahead and tell me in the chat, 8 protons, 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 protons. Should I make that a positive 8 or a negative 8? Tell me in the chat. Should I make this a positive 8 or a negative 8? Yeah, I'm going to make this a positive 8. So protons are positive, so I'm going to go ahead and plug this in as a positive or regular 8. And electrons, what should I make that? A positive 9 or a negative 9? Electrons, should I make that a positive 9 or a negative 9? Thank you, Landon. Thank you, Julie, Ronnie, Monse. Yes, Dima, exactly. So many people. Yes, this would be a negative 9. I actually already have that negative sign plugged in for us. That makes it easy. Remember that when you add a negative, that's like adding debt. And so you actually are doing subtracting. So adding a negative is actually the same as subtracting. So this is the same as saying 8 minus 9. So go ahead if you need to. Absolutely grab a calculator just to double check your answer. But I think you could probably do the mental math here. 8 minus 9, keeping in mind you have more negatives. So think about your answer. Should it be overall positive or negative if we have more negatives? There we go. Getting lots of great answers in the chat. Thank you, Lauda, Andrew, Julie, everybody else. Yes, you should be getting a -1. Make sure you know how to do this. We're going to practice one more. You will need to be able to do the next one on your own on the next slide, so make sure you're practicing with us. So again, let's say we again have that same neutral atom. Sorry, I did want to mention. So again, taking a look here, we had a neutral atom, we gained electrons, and so we again ended up overall negative. We gained negative friends, we end up overall negative. So that should make sense that our charge here ended up being a -1. Okay, now let's go ahead and say we had that same neutral atom, 8 protons, 8 electrons, but this time we lose an electron. So we have only 7 electrons now. So again, let's participate in the chat. What is 8 protons? Positive or negative 8? Positive or negative 8? Yeah, this is going to be a positive 8, exactly. And then right here, 7 electrons. Would that be positive or negative 7? Positive or negative 7? Yes, electrons are negative. So one more time, that's a -7. So again, adding a negative is the same as subtraction. So this is the same as saying 8 minus 7. So tell me in the chat, 8 minus 7, do that mental math and tell me what is our charge when we lose an electron. When we lose an electron. Yeah, in this case, it's just going to be 1, right? So we have a positive 1 charge. Again, that should make sense because in this case, we actually lost electrons. So just like if you lose negative friends, you actually end up becoming a more positive person. Okay, so that all looks good. I feel like we're pretty confident with how to calculate charge. Now, I do want to go back to this idea of protons, atomic number, and identity. Now, you'll notice that both of these ions had the same number of protons. So therefore, tell me in the chat, if they have the same number of protons, are they the same identity? Yes or no? If they have the same number of protons, are they the same identity? Yes or no? If protons is atomic number and is identity, if they have the same protons, should they have the same identity? Yeah, they actually should have the same identity. Again, protons and atomic number and identity are all the same thing. So if you have the same number of protons, you actually have the same exact identity. It's just that one of these atoms with the same identity is negatively charged, one of them is positively charged. So let's figure out the identity. So again, we had 8 protons. All right, so that's going to be related to the atomic number. Go ahead and tell me in the chat, what is the identity of both of these ions? Both of these ions, what is their identity? I see Jalen working in the chat. They're the same identity. You should either be telling me nitrogen or oxygen or fluorine. They are the same identity. We have 8 protons. Find the atomic number 8. Which one has an atomic number 8? Protons equals atomic number equals identity. There we go. Yes, fixing our mistakes. Love it. Yes, this is the atomic number 8. And so oxygen is the only atom that always has 8 protons. So 8 protons. And so both of these ions are actually oxygen. It's just that one is negatively charged and one is positively charged. Go ahead, give me a smiley or an emoji in the chat box if that makes sense. Again, both of these are oxygen. They are both oxygen. Again, electrons can change all they want. It will still be oxygen if it always has 8 protons. This is the answer to number 2, number 3, and number 4. Please raise your hands once you have this completed in your notes. I'm going to go ahead and set a timer for 20 more seconds.
On the different types of ions. First of all, on the left-hand side with the green text, we have a neutron atom that loses negative electrons that becomes more positive. Is called a cation. So a cation, we have a couple ways of remembering this. The surefire way is that if you associate the letter T with looking like a plus symbol, which is pretty easy because they both have a cross in them, that will give you that visual indication that the word cat with the T in the center means positive. So cation is a positive charged atom. Another way that I personally learned that is especially if you have a pet cat, that cats love to paw things. And so if you are positive, like a paw, then you are a cat ion that is positive. All right. Then with the right-hand side with the pink text, we have a neutral atom that gains negative electrons to become more negative is called an anion. One way to remember this is looking at the word an, looks like anti. Anti is kind of like the opposite of what we originally were talking about. So anti meaning anion would be negative. All right. Important thing to learn here is that no matter what we have, if it's a cation, it will always have more protons than electrons, versus an anion will always have more electrons than protons.
Okay, so this one we're going to go ahead and make sure that you are able to do on your own. I'll go ahead and annotate with you though, just to make sure we're feeling confident about this. So the question is, what is the charge of an ion that has 7 protons and 10 electrons? Go ahead and tell me in the chat. Protons, should that be a positive 7 or a negative 7? Protons, should that be a positive 7 or a negative 7? Thank you, Monse. Thank you, Landon. Micah. Yes, exactly. This one will be our positive 7. And then electrons, should that be a positive 10 or a negative 10? Positive 10 or a negative 10? Yes, electrons will be negatively charged, so that will be our negative 10. Don't forget that when we add a negative, that's the same as subtraction. Do not put answers in the chat for the final answer, but again, I did help you annotate that. Again, reminder, cations, are those the positive or the negative ions? Cations, are those the positive or the negative ions? Think about cats. Cats are Positive. Yes, they're positive. So yes, this one's the positive type of ion. This is the anions are the negative type of ion. So depending on what your charge is, if your charge is positive, then you're a cation. If your charge is negative, then you're an anion. All right, so make sure that that makes sense, that whatever answer you get here for charge will tell you if you're a cation or an anion. And finally, the identity or the atomic number of this ion is related to what? Identity atomic number is related to what? We have these atomic numbers at the top. This is related to the number of what? Thank you, Micah. Thank you, Jalen. Tell me in the chat, atomic number is related to protons. Yes, exactly. So don't forget this is related to protons, of which you do know the number of protons that this ion has. That was told to you at the start. All right, so go ahead and work on question number 5. If you need help, we're in the Q&A chat. You have 45 seconds to work on this. Go, go, go. So we've talked all about ions now. Now we're going to go ahead and talk about the ionic bond, which this should make sense. It has the root word ion in it. So an ionic bond is just the attraction between a cation and an anion, because cations are positive, anions are negative, and they're opposites. Opposites attract. We have this idea in physics that opposites attract, whereas likes repel. So if you have an opposite cation with an anion, they're going to be attracted to each other, and that results in a bond. Now remember, the purpose of bonding is that atoms do want complete valence shells, usually that 8 outermost electrons, the octet rule. They want that octet rule. But keep in mind that so far we've been talking about atoms pretty separately from each other. We've said, oh, you know, metals will lose electrons, nonmetals will gain electrons, but we haven't talked about where those electrons come from or where they go. So here's the deal, they're actually going to each other. So these electrons are actually being exchanged between atoms, which is resulting in the bonds that we will be learning about in this unit. Let's go ahead and talk about our first example. We'll talk about the comic in just a moment, Jalen, because it is relevant. Sodium, or Na, is a soft metal. It has one valence electron, and it will prefer to lose its one valence electron. So if it loses a valence electron, that's like losing a negative friend. So tell me in the chat, will it have a positive or a negative charge? If you lose a negative friend, will you become more positive or negative? Yes, absolutely. Losing negativity, you actually become a more positive person. Excellent. And therefore, does that make you an anion? An like anti, or a cation? Cats are what? Go ahead and tell me in the chat. Is this an anion or a cation? Anion or a cation? Yes. Cats are positive, and so a positive charge will become a cation. All right, so we have our sodium becoming a positive cation. Cool. Now that's great, but we still need an anion. We still need the opposite one for there to be an attraction, for there to be a bond. Now again, I'm telling you, atoms don't just throw electrons to the wind, right? Sodium's not just going to be like, here, universe, here's an electron. That electron has to go somewhere. So specifically, it's going to go to another atom. In this case, it's going to go to chlorine. Chlorine is in group 17, so it has 7 electrons. It just needs one more. And so that greedy chlorine is going to take or gain that one valence electron. We saw this yesterday. We saw chlorine as that yellow gas. It's a nonmetal. It's going to actually steal or take that electron that sodium gives up. So now, if you're gaining negative friends, do you become positive or negative? Chlorine is gaining a negative friend, a negative electron, so should it become overall positive or negative? Yeah, it's going to become overall negative because it's gaining negativity, right? And so in this case, what does that make it? An anion or a cation? Anion or a cation? Thank you, Micah. Thank you, Jalen. Yeah, this is going to become an anion, right? We can see that an, like anti, it's the opposite one. It's the negative one. The grumpy one. The anti-ion is the grumpy one. Okay? We have a positive sodium now and a negative chlorine. That means that they are opposites and opposites attract. So this actually creates their bond. You can see an example here. We have sodium being positive, giving some negative electron flowers over to chlorine. Chlorine saying OMG, and chlorine becoming negatively charged. And he says, they say opposites attract, and so now they are oppositely charged, they are attracted, they are going to stick together in a bond, and that bond creates sodium chloride, which we learned yesterday is also known as what? It is also known as what? There are some chemicals that you should be very familiar with because we talk about them in everyday life. Sodium chloride is the same as what? What do we eat every day that is called sodium chloride? Thank you. I see Micah in the chat. I see Marina. Yeah, this is just table salt, the salt that you literally have on your table. This is going to be the answer to number 6 and number 7. Please do not write out the whole word positive or the whole word negative. Just put in exactly what you see in the boxes. I didn't want to make it more complicated. So literally what you see in these red boxes, that's the answers for 6 and 7. Go ahead and raise your hands when you have those ready. You have 30 seconds to get that done. Raise your hands. Go, go, go. We can see here, again, sodium has 1 valence electron, whereas chlorine has 7. So sodium wants to get rid of its 1, and chlorine is like, I'm so close to having 8, I just want 1. So again, these atoms are not just operating by themselves, they are working together. You can see that sodium actually gives its electron to chlorine, and now sodium, having given away an electron and lost a negative friend, becomes positively charged, and chlorine, having gained that negative friend, now becomes overall negatively charged. Once they're positives and negatives, they are attracted to each other, and that creates a strong bond between them. Please give me smiley, medium, sad face if that's beginning to make sense, if you understand that. By exchanging the electrons, one becomes positive, one becomes negative. That is an ionic bond. You have ions, that is an ionic bond. Okay, now let's go ahead and connect this back to what we talked about with metals and nonmetals. All right, so metals only have 1 to 3 valence electrons. So tell me in the chat, what do you think will be easier? Will it be easier for metals to gain electrons to fill their current shell, or lose electrons to drop down to a full shell? Thinking back to that octet rule, they only have 1 to 3 out of 8 electrons, 8 valence electrons. Yeah, if you only have 1 to 3, it's going to be a lot easier to just lose the 1 to 3 than to have to try to gain a bunch more to get to 8. So this means if you're losing electrons, are you going to become more positive or negative? If you're losing electrons, losing negative friends, do you become more positive or negative? Yeah, so metals absolutely are going to become more positive. And so go ahead and circle on the board for me. If they're becoming more positive, does that make them a cation or an anion? Go ahead and circle the correct term on the board for me underneath metals. Metals, if they're becoming more positive, are they cations or anions? Amazing. Yes, they become cations because cats are positive. And taking a look here, you can actually see this right here, that these groups 1, 2, and 13, all become positive cations, right? We can see group 1, they lose 1 electron. They lose their 1 electron to become overall a positive 1 cation. Group 2, they have 2 valence electrons that they lose to overall become positive 2 cations. And group 13, they have 3 valence electrons, so they lose them to become overall a positive 3 charge. Let's go ahead and try nonmetals up on the whiteboard. So nonmetals this time on the right side of our periodic table already have 5 to 7 of their valence electrons out of 8. So go ahead and circle on the board what's going to be easier, to gain or lose electrons. And therefore, will they become cations or anions? Go ahead and answer both questions up on the board. Excellent job, everybody. Okay, let me go ahead and pause those tools. Yes, so if they already have 5 to 7 out of 8, they just need a few more. It's going to be much easier to gain electrons to get to that full octet. And if you're gaining electrons, that's like gaining negative friends, and so you become more negative overall because you're gaining negativity. And negative ions overall are called anions. And again, we can see that here. Nitrogen has 5 valence electrons. It just needs 3 more. It gains 3 more to become negatively 3 charge. A negative 3 charge, a negative 3 anion. Whereas group 17, they have 7 valence electrons. They just need 1 more. They gain that 1 more to become a negative 1 anion. Smiley faces emojis in the chat box if you feel more and more comfortable with this. Again, metals will become cations. Nonmetals will become anions. We actually already saw this with sodium and chlorine. Sodium, our metal, became a cation. Chlorine, our nonmetal, became an anion. Amazing. All right, let's go ahead and wrap this up and make sure we feel confident with this. Here we go.
All right, everyone. So let's do one final complete on your own question. So I will introduce it to you, and then we will be in the Q&A chat to help you with any questions you may have. But just be sure to try it on your own first, and please do not post any answers in the main chat. All right, so we have three terms being cation, anion, and ionic bond. And with the definitions, we have something having an overall positive, being an overall positive ion, something being an overall negative ion, something attracting between oppositely charged ions, and two other things having more electrons than protons, and one having more protons than electrons. All right, so a lot of these definitions and terms we reviewed during the notes today, so don't hesitate to look back in your notes to see where these were used in the stuff we've already covered. All right, guys, so great job with today's lesson. We reviewed how to calculate the overall charge of, on an atom being a cation or an anion. We also learned what those meant again, and we explained how ionic bonds are formed, kind of just like passing a ball between you and your friend, and then explaining how metals and nonmetals lose or gain valence electrons. All right, we're just gonna skip that just for now because we're short on time. But if you haven't already, go ahead and submit your quiz. If you have no questions or do not need any assistance in the notes, go ahead and leave the class, move on to your next one, and we will see you guys tomorrow. Take care.